Why is deep space exploration limited by propulsion? Imagine trying to travel across a vast ocean in a small boat. Now think about exploring the enormous stretches of space beyond our solar system. It's a huge challenge, and propulsion is at the heart of it. Right now, the main way we send spacecraft into space is with chemical rockets. These rockets burn fuel to create thrust, pushing the spacecraft forward. But chemical rockets have a big limitation. They don't store a lot of energy for their weight. This means they need to carry a lot of fuel, which makes the spacecraft heavy and limits how far and fast they can go. For missions beyond the Moon or Mars, carrying enough fuel to reach distant planets and return is just not practical. Chemical propulsion is powerful for launching from Earth, but it's not efficient for long trips. It provides a lot of thrust for a short time, but that's not enough for traveling across the huge distances in space. The longer the trip, the more fuel you need, and that makes the spacecraft heavier and more expensive to build. To get around this, scientists are working on alternative propulsion methods. Ion thrusters are one example. They use electricity to accelerate ions, which creates a gentle but continuous push. These thrusters can operate for thousands of hours and gradually build up high speeds. The problem is, they produce very low thrust, so they can't lift off from Earth or make quick maneuvers. They are mainly used once the spacecraft is already in space to slowly increase its speed. Another promising option is nuclear propulsion. These systems use nuclear reactions to generate power and thrust. They can produce much higher and more consistent energy than chemical rockets. This could cut travel times significantly and allow spacecraft to carry larger payloads. But nuclear systems face hurdles like radiation shielding, safety concerns, and added weight. Developing these systems is complex and costly, and they requiring careful planning to ensure safety for astronauts and the environment. For astronauts, propulsion limits mean longer trips in space. They need special training to handle extended microgravity conditions and to stay healthy during months or even years of travel. Life support systems must be designed to keep crews alive and comfortable for long periods. Launch windows are also affected, because spacecraft can only leave at certain times when conditions are right. This makes mission planning more complicated and less flexible. In short, our current propulsion technologies just aren't enough to make rapid, long-distance trips in space easy or affordable. Advances in electric and nuclear propulsion are promising, but they still face technical challenges. Until those hurdles are overcome, the limits of propulsion will keep deep space exploration within certain boundaries.